which is being conducted for the first time with this sort of say topic in our country. As you know, JNTUH is one of the premier technological universities, including the students. Within this short span of 15 weeks, the students have come out with flying, say, MAVs, which will be demonstrated on the third day. During the next 2 days and today's afternoon, there will be many eminent people who will be talking about the various technologies which go into the making of MAVs. So I don't want to preempt that. Suffice it to say that MAVs have got a lot of, say, applications in the near future, especially in view of the fact that they'll be able to do certain things which are not possible by human beings. Some of the applications in tasks what you can expect from MAVs are sea rescue searches from the air, border patrols, state-of-the-art sensors, and low power, low cost, lightweight computing platforms.
Good to have industry background when you are in the academic field. There are going to be a lot of benefits. I'm sorry I'm doing a little rushing because of obvious reasons. But the message is, as far as the mini and micro UAVs are concerned, we have adequate knowledge, adequate technology. Industries are quite capable. Both you have seen student community, industrial community, small, medium scale. Flight testing is possible because DRDO has established both at Bangalore, ED Bangalore, and here at Hyderabad. We have got many types as picture being, rotary being bio-inspired. Especially the biology, we are integrating everybody as you see. And also the biology and the engineering, physics, mechanical, the way it integrates, you go to do wonderful change. And the bio-inspiration useful because the way the energy efficiency in the biosystems is we are not achieved in the physical systems. So can we learn from biology how the energy efficiency? For example, a bird can fly 1,000 kilometers. It will only burn a few grams of protein. When it flies 1,000 kilometers, if you see the bird's weight, it has lost only a few grams of its weight to fly 1,000 kilometers. The efficiency, the bioenergy efficiency is something where we can nowhere achieve. So can we get ideas how it moves, how efficiently it consumes. Swarms, this is called ad hoc wireless networks in the air. That is, we have a number of UAVs. They talk to each other. They are self-organizing network. They are self-healing network, self-management network. So if you send 100 UAVs into one area, they can communicate with each other and decide what to do and how to do. One. Now coming to the technology challenges, are there reasonably, any big challenges? There are very robust systems and they have longer and longer endurance, and they require range also, high range, maximum you can give, and the capability to fly under all adverse conditions, windy conditions, rain conditions, and how do we still sustain and get you the information what you're looking for. And it should be able to hover, it should be able to perch, it should be able to stay, and it should be able to, and then keep sending you whatever information you're looking for. And the aerodynamics is a big challenge because of the low Reynolds numbers. How do we handle it? And then how do you make it control? For example, people are doing research without control surface. Can you fly UAV without control surface? Then you will reduce a lot of drag, reduce a lot of weight because all the actuators can be removed. Can you remove the actuators? Can you have roll control, pitch control of a UAV without having any control surface? This research is being done using fluidics. If that comes through successfully, you will have very light UAV, almost like a bird, it keeps flying.
Very much, sir, for bringing out the applications of MAV. specifically disaster management. I'm sure, in fact, there are many more applications. In fact, in an informal discussion, Dr. Prahlada was just mentioning, why not we have one more workshop on disaster management. I'm sure that JNTUH University will come forward, will join hands with you, and definitely will do one more conference of international nature on disaster management. Professor Sanjay Govind Dhande, former Director IIT Kanpur, to present his keynote address. Thank you.
We had decided not to just develop and launch the micro nano satellite, but there are technologies to be developed, and the most interesting part of the MAVs is that the component technologies that go into it, you will find that that is what is the challenge is there for the academia and the research group. The first one we developed was a micro imaging system. As a matter of fact, you will find that the imaging is a very challenging job. And increasingly you will find that the photonics, in order to navigate it, you must have the full control over the pitch, yaw, roll, as well as the location of the vehicle. And therefore this inertial control unit, as we call it, the inertial measurement unit, required a lot of accelerometers to be placed. These accelerometers are not the normal accelerometers, but these are miniaturized accelerometers, and therefore you need to test them before you can even use them. Then obviously the onboard computing. This is another important aspect which has changed the technology. A whole lot of ball game related to unmanned aerial vehicles, the micro aerial vehicles have changed completely. And therefore the communications aspect, and particularly the digital communication aspect, is a very important part, and that is the umbilical link with the ground station in some sense. And finally it is the advanced control system, that is the orientation and the digital control system that we have put on the satellite. So these are some of the subsystems, all of it is packaged in 10 by 10 by 30 centimeters, as you can see, and I will show you a little bit of more details about it. Before that, I just have to show you, of course, those of you who are more interested in the what you can call the YouTube, there is a video of 3 minutes about this activity. Anyone can go on to the YouTube and then see it